You're listening to international investment advisor Doug Goldstein on the Goldstein on Gelt show, the financial show where we'll talk about how you can make the most of your money. With all the confusing financial chatter bombarding you each and every day, Goldstein on Gelt will give you the practical information you want and need about living a financially stable life. Here's your host, money maven Doug Goldstein.
Okay, we are back. We are talking to Professor of Psychobiology Matti Mintz. He's in the Department of Psychology at Tel Aviv University, and we found him because he was named on ABC News as the founder of the Robo Rat. So, Professor, I'd like to welcome you to the show.
I'm very pleased to be with you. Thank you for inviting me.
I'd like to understand that this Robo Rat is a hybrid of a biological and a synthetic rat. Can you tell us about that?
Yes, actually, I'm very happy that you use this term of hybrid rather than cyber rat or something like that. Cyber rat is kind of public term. We in the academy rather use the term hybrid. And so the question is whether we can help a person or that is damaged in one part of the brain, whether we can help recovery of this lost function because of the damage. And so there are already many examples that we are actually using this electronics or informatics technology that we can actually help some of these people. The known examples are Parkinson patients, where you stimulate some area, subthalamic area in the brain, and you see that although Parkinson is not cured, but you see that the symptoms are taken care of.
Okay, so just to touch on this rat, just because that was what was so famous and exciting, you connected something to the rat's brain that allowed you to have some control over it?
Well, so you see, so just let me just finish with this Parkinson patient, because this is leading me directly to what we have done. So they are stimulating the brain. Others are recording from the brain. And so ourselves and the colleagues through the history of neuroscience, we actually gained a lot of control of recording from the brain and stimulating the brain. So the next idea we had, together with some other researchers, of course, around the world, we had this idea of connecting the recording electrodes to the stimulating electrodes by some smart synthetic device. Let's say it's in the beginning a program. So you record from a place in the brain, you analyze this information, and you provide stimulation back to the brain, trying to correct something. Okay? So our idea was that we can actually correct some a function that is lost because there was a damage in the brain. So just imagine you have very tiny place in the brain that was damaged because of aging or because a lack of blood supply or because some accident or because some toxin, but we speak about very tiny place in the brain. And so we record from the inputs to this tiny place of the brain. We analyze the information in the synthetic device, a chip or a program, and we try to analyze this information in a very similar way to the way the original place in the brain was analyzing this information. And we return the analyzed information, the decision, back to the brain. So if you like, it is kind of a side loop that is correcting the function that was lost because small damage to the brain. This is basically the idea.
So let me just make sure I understand. So let's say that someone or a rat, for example, loses the capacity to move a finger, or whatever rats have. You would find that spot in the brain which moves his finger, and you could implant something there that would sense when he wants to move his finger, and then it would send a signal back to the finger to move.
Exactly, not to the finger, to the area in the brain that moves the finger, actually.
Okay. Okay, so you're sort of reading his thoughts.
So I'm kind of reading not his thoughts, but I'm reading partly the information that is that reflects the decision to move the finger. Yes.
Okay.
Actually, yes. So we know, however, already for many years to read this kind of information. This is not new. I mean, we know we know to record from arcs of reflex to record the sensory information that is coming that we know that has to lead to some movement, and we know to do it already for many decades.
But this is not the same as understanding what someone is thinking in sort of the science fiction mode of reading someone's mind, is it?
Absolutely, absolutely. So I stress that we are replacing very tiny place in the brain, replacing this very tiny. So let's say you have a long sequence of movements that you decided to make, and within this sequence, we are providing you a replacement for one of these movements. So it is far away still from knowing what you think. But in this sequence of behaviors that you want to execute now because of decision to move around, one of these movements was impossible because there was a damage in the brain, and we are giving you the option to execute this small movement within a longer sequence of movements.
Let me just reintroduce for people who are joining us now. We are talking to Professor of Psychobiology at Tel Aviv University, Matti Mintz. He's talking about the work that he's doing to make a hybrid between a biological brain and a synthetic device. It became very famous because of a rat that they did some experiment on, where the rat actually had disabled cerebellum, and then they put a device into his brain, and it allowed the rat to return to normal activity. And so we're talking about what some of the applications might be of this device.
Okay, just a small remark. You said now just to the audience that we replaced the cerebellum. Cerebellum has more cells than any other site in the brain. So we didn't replace the whole cerebellum. This would be, for me, kind of Herculean task. But we speak about replacing one small part of the cerebellum. This is the state of the art now.
Okay, so are there any applications outside the laboratory yet, or are we still waiting for that?
Well, part of the applications are already in the hospitals. They are performed in the hospitals. People are now implanted with electrodes to correct motor movements, to help recovery from obsessive-compulsive diseases. There are attempts to recover depression. Sometimes there are recordings from the brain to discover sites of epileptic fossa in the brain, etc.
Okay,
this kind of application that we speak, adding some smart device between the recording and stimulation of the brain, we are not aware that such a device is yet in the clinical use. But we think that some applications of this kind of device will be in future years already introduced to clinic as a clinic tool. Which parts of the brain can be function of which parts of the brain can be recovered by this technique is still a question. Another group, for example, in working in USC in California, in Los Angeles, is trying to replace much bigger part of the brain compared to what we are doing. They try to replace hippocampus, that is important for spatial orientation, for memory, etc. And they are making a lot of progress. So I think, I believe that in future, small parts of the brain, at least, you will be able to replace.
So what's the focus of your lab right now?
So we are now trying to expand our expertise, and instead of working on one single discrete motor movement, we want actually to recover now a sequence of movements. Let's say you want to move your hand, and after moving your hand toward the table, you want now to grasp a glass. So here it is already not one movement that is involved, but rather a sequence. So now the question is whether we can actually benefit from the techniques that we mastered during this project to replace longer sequences of movement. And so this is very challenging, of course. Much more technology is needed. And this kind of project involves many partners that build for us electrodes, array of electrodes, partners that build simulations, build chips, integrate the whole technology together, signal analysis, signal processing. So we are trying now to build this group again and convince my partners that we can actually now approach much more difficult tasks that will involve slightly bigger area of the brain. Still not the whole cerebellum, definitely not, but bigger part of the brain.
So right now we're dealing on the academic side of it. Let's say that there is going to be some sort of move into the business aspect. You're doing it more from a study point of view, but are there companies that are involved today that perhaps in the future will be a common name because everyone's going to say, well, I had my brain fixed by such and such a company?
Well, first of all, this study was, the budget for this study came from Israel, from ISF and from Complexity Science Project. Funding institution, but mainly from European community. And so they require from us cooperation, and they are funding only studies that are of large scale in a sense that several principal investigators are cooperating. So one of the cooperating partners was in fact a company in Austria that was building for us the integration system for all of the technologies. So there is some kind, and through this experience, they started to develop more and more sophisticated equipment. So this is already proven impact on economy of Europe economy, at least, or one company. But when we are developing this complex technology, this integrated technology, there are many small parts of this technology that are already patented by us. Mm-hmm. So, for example, one of my students came to the idea that if we want to recover function in the brain, we need to implant electrodes that will be functional in the brain for many years, actually. And electrodes, when they are inserted in the brain, they damage the brain and they trigger response of the immune system, which is encapsulating the electrode and preventing it to function properly. So he found a way to antagonize the effect of the immune system. And this is already a patent.
Amazing.
That my university accepted. And if companies will be interested in this kind of improvement in the electrodes, and many companies are, including states, are now producing these electrodes for brain recording and stimulation, this is definitely something that is enhancing the market, or the economic market in Israel, definitely.
Wow.
And we expect that more of this kind of improvements will come when we progress in the project.
Well, that's truly amazing. We've been talking to Professor Matti Mintz. I'm sorry, Professor, we are almost out of time, but maybe just in the last few seconds, could you tell people how could they follow the work that you're doing?
Each one of us is now having his website. My website is now under the reconstruction, so it is kind of closed. But if people will come to the website of our project, and I will give now the name of the project, then all of the partners are there, have their websites stated. So the project was called RENA-CHIP. RENA-CHIP is an acronym for rehabilitation, so it is RE, nano, NA, chip, RENA-CHIP, rehabilitation nano-chip. So if they will go to this website of RENA-CHIP, this is the only original name of the RENA-CHIP that is existing in this on the web. So they will find all of our partners. The partners are coming from Tel Aviv University. I have partners here from School of Engineering. I have partners in England, Austria, as I mentioned before, Italy, Rome, and Barcelona, and also in Lund in Sweden. So all of these partners are mentioned there.
Wow, fascinating. Okay, so that is renachip.org, RENACHIP. Professor Matti Mintz, thanks so much for your time.
I'm very happy to speak with you. I was very happy to speak with you.
You've been listening to the Goldstein on Gelt show with money maven Doug Goldstein. Doug's weekly radio show is heard around the world, but if you miss it, you can download the podcast at www.goldsteinongelt.com. The Goldstein on Gelt show gives you up-to-date financial ideas so you can get on the path to financial freedom. If you'd like your questions answered on the air or off, send Doug an email to doug@profile-financial.com. It's your money for your future, so join Doug every week to build your wealth on the Goldstein on Gelt show.